Let's try to learn about projectile motion. Here we'll obtain the formulas and equations of projectile motion. Projectile motion is divided into two components, X component and Y component. Here we will move in three steps. In phase 1, we'll find out all quantities at initial time, or we can say at t equal to 0 time. The first quantity which we need is position. So initial position R bar will be x0 I cap plus y0 j cap, where x0 will be its x component and we are considering origin. That's why that will be 0. And y0 is also 0. Now the next quantity which we need is velocity. Initial velocity v0. And it will also have two components, v0x plus v0y. Here we are considering the magnitude of velocity is v and angle with positive x-axis is theta. That's why its x component will be v0 cos theta and y component will be v0 sin theta. And the third important quantity is acceleration. Acceleration is only due to gravity and that is only vertically downward. That's why the x component of acceleration will be 0 and y component will be minus g. So here we complete our first phase. Now let's move to the second phase, in which we have to find all quantities at t equal to t time. So let's begin with the position. Let's say we have position of R bar, X and Y, and we'll use formula of distance, which is V0t plus half at square. So to get X component, we need X component of initial velocity into t plus half X component of acceleration into t square. We already find out X component of velocity as v0 cos theta. So we'll get v0 cos theta into t plus acceleration is 0. So your second term will be 0. So we get equation of X. Now similarly, let's try to obtain Y. In this step, we need Y component of velocity and Y component of acceleration. Your Y component of velocity is v0 sin theta. So we'll get v0 sin theta t as your first step and your acceleration is minus g. So this will become minus half g t square as the equation of y. Now let's try to obtain equation of projectile, and for that we have to make t subjective from first equation. So we'll get t equal to x by v0 cos theta and substitute the value in second equation. So we will get y is equal to v0 sin theta into t. So we'll get x upon v0 cos theta minus half g into t square, or we can say x square upon v0 square cos square theta. Okay. Now in first term, v0 will be cancelled out and we'll get y is equal to this sine upon cos become tan theta into x minus we have g upon 2 v0 square cos square theta into x square. So we can say we get standard equation of projectile motion, which is actually in the form of y is equal to ax minus bx square, which is equation of parabola. Now let's go for the second quantity, which is velocity. V bar having x component as vx and y component as vy, and to find this we will use equation v equal to v0 plus at. So let's try to obtain x component. We need v0x plus acceleration in x direction into t. So let's get x component of velocity, which is v0 cos theta, plus x component of acceleration, which is 0. So we don't have to worry about it. So your x component will be v0 cos theta. And now we have to find out y component of velocity. So we need v0y plus ayt, where your y component is v0 sin theta and y component of acceleration is minus g. So we get vy is equal to v0 sin theta minus gt as y component of velocity. So here we complete our second phase. We get all required equations to describe projectile motion. Okay. Now let's move to the third phase. In this phase, we'll try to find out time to achieve maximum height, time of flight, and range. So let's begin from time to achieve maximum height. So we have to consider t equal to tm. At maximum height, the y component of velocity is 0. So let's use equation of y component of velocity and substitute the values. Your y component of velocity is 0 and time is tm. So if we move this term on the right side, we will get g into tm is equal to v0 sin theta. But as you know, we need tm. So let's make it subjective by moving g on the right side, but it will go into the denominator. So here we get your time to achieve maximum height. Now let's go for maximum height. That means your y will be h max, and this will happen at t equal to tm. So we have to use equation of y. So let's get it over here and substitute values. Your y is nothing but h max and t is nothing but tm. So this term will also become half g tm square. Now let's substitute value of tm. So your first term will be v0 sin theta into tm, which we find as v0 sin theta by g. So your second term will become half g into tm square, or we can say v0 square sin square theta by g. So the first term will become v0 square sin square theta by g, and second term is half of that. So your final answer will be v0 square sin square theta by 2g. So we get the equation of maximum height. Now your third required quantity is time of flight, a time where it will back to the ground. That means your y will become 0. So again we have to use equation of y and substitute the values. Your y is nothing but 0 and time is tf. So we'll get tf square. Now let's move this term on the right side. So we'll get half g tf square is equal to v0 sin theta into tf. So here we can reduce 1 power of tm, and to make tf subjective, we have to move g on the right side, go into the denominator, and 2 will go into the numerator. So we get equation of tf. And finally, to get range, which is distance covered in x direction during t equal to tf time, can be found using equation of x. We just have to substitute values. Your x is nothing but range and time is time of flight. So let's substitute value of time of flight, which we find as 2v0 sin theta by g. So here we have V0 into V0, or we can say V0 square upon G, and in trigonometry 2 sine theta into cos theta is nothing but sine 2 theta. So we get equation of range. So tada! Here we complete our projectile motion.